Hi, everybody. I hope you're all having a great reInvent so far. My name's Akshata Ketkar, and I'm a senior program manager on the Outpost product team. I'm really looking forward to chatting with you all today about how to simplify your hybrid cloud migration strategy with AWS. And I'm especially looking forward to inviting two of our customers, Jonathan and Anusha, to the stage to share about their experiences driving a hybrid cloud migration at their respective organizations. I promise by the end of today's session, you'll leave feeling inspired to drive a hybrid cloud migration at your organization, and you'll also leave equipped with the knowledge of the AWS solutions that we have to help simplify your experience. All right, so on the agenda for today's presentation, we'll discuss reasons why your organization can benefit from migrating to the cloud. Next, we'll discuss application migration strategies. Then we'll conduct a deep dive on the AWS solutions that are there to help drive your hybrid cloud migration. And during that deep dive, we'll be inviting Jonathan and Anusha to the stage. I want to quickly take this opportunity to define the term hybrid cloud. The term hybrid cloud has been used in a variety of different ways, in different contexts, and different use cases. So for the sake of this presentation, I'll be using the term hybrid cloud to refer to our continuum of AWS services that bring the cloud closer to wherever you need it, whether that's in our regions, on premises, or at the far edge. All right, so why should an organization migrate to the cloud? In order to illustrate my point, I'm going to introduce you to Diego. Diego recently joined a company that specializes in multiplayer gaming. Gamers across the world enjoy playing games with one another via live streaming. And over the past year, Diego's company has taken the effort to migrate many of their applications to the cloud, specifically those applications that are lesser latency sensitive. Migrating those applications has enabled Diego's company to benefit from a wide variety of benefits that you get from the cloud. To name a few, you've got increased scalability, lower costs, and a better developer experience. Given the success of their migration thus far, Diego's company is eager to migrate all of the remaining applications that their company runs to the cloud. And they've charged Diego with developing a migration plan as his first big project. However, Diego faces a challenge. So the remaining applications that his company is yet to migrate are latency sensitive, as these applications are used for building and driving game streaming. Applications that are used for game streaming are subject to very stringent latency requirements, because gamers expect a latency of 30 milliseconds or less for an ideal gameplay experience. As you likely already know, latency is dependent on the physical distance between where an application is deployed and where its end users are physically located. In order to meet their latency requirements, Diego's company needs to retain their applications and workloads close to where their end customers are. And in the past, in order to accomplish this, Diego's company needed to maintain their own local infrastructure close to wherever their customers were. This proved to be a high operational burden for his IT specialists, as they needed to procure, provision, and manage all of this hardware. In addition, with the company's recent migration of a portion of their workloads, this would also prove to be highly complex for Diego's development team, or Diego's company's development team, as they would now need to operate in two different technology stacks. So here's where our AWS hybrid cloud solutions come in. By leveraging our fully managed hybrid cloud services, Diego can simplify the infrastructure management for his for his company's IT specialists and improve the developer experience for his company as well. Diego can leverage AWS Local Zones to move applications closer to where customers are in industrial or metropolitan centers. He can also leverage AWS Outposts to retain certain workloads on premises. And he can also leverage AWS Snow Family in case he has workloads that need to operate in disconnected scenarios. I'll be providing more details on all of these service families in just a bit. All right, so I'm sure many of you are already familiar with the benefits of migrating to the cloud. And I've touched on a few of these already, but I think it's worth reiterating really quick. So the first of the benefits that we see of migrating to the cloud is rapid scalability. As you know, you can scale up infrastructure as needed to support your evolving workload requirements with the cloud. We also notice reduced operational costs. As you no longer need to install and maintain your own hardware, and AWS takes over that responsibility with our fully managed set of solutions. Migrating to the cloud also helps simplify your IT, as hybrid services do away with the complexity of procuring, provisioning, and managing your own hardware. We also see improved developer productivity, as developers now have instant access to a broad set of services, APIs, and tools. Lastly, we noticed an acceleration in business innovation, as our cloud services help unlock new features, such as lower latency and data residency, which were previously unavailable with the cloud. All right, so now I want you to put yourselves in the shoes of Diego for just a minute. Let's suppose that your company has put you in charge of developing a migration plan. How would you go about developing a strategy? At AWS, we consider 3 strategies to be core to our hybrid migration journey story. Assessing which of these migration strategies is best suited for your workloads will be dependent on the kind of applications that you run, and it's important that you take into account both your application's business and technical needs when making a decision. So the first of the migration strategies that we see customers commonly employing is rehosting by lifting and shifting. So in this scenario, an application is moved to the cloud with minimal or zero re-architecting. The second strategy that we notice customers employing is rehosting, retooling, and replatforming. So in this scenario, an application is re-architected to better suit our cloud platform. And the final of the strategies, and the strategy that we're focusing on most closely in today's session, is retaining on-premises. So we believe that in most cases, applications are well suited for lifting and shifting or refactoring, replatforming, and retooling. However, as with the example I just provided of Diego, there will always be workloads that justify a need to be retained on-premises, or at least closer to where customers are. So let's discuss some common use cases for retaining workloads on-premises. I already provided an example of Diego, and Diego represents that example of single-digit latency or local data processing. Now, we also see customers with complex legacy applications that are difficult to lift and shift without disrupting business-critical operations. And Jonathan and Anusha will actually be providing examples of complex legacy applications that they migrated. As I mentioned, Diego is an example of our single-digit latency or local data processing requirements. And these sort of workloads must run close to their data sources or backend systems which they're tightly coupled to, or are subject to challenging latency requirements for end users. And then the last of our use cases is data residency. There are some industries or geographical regions which are subject to laws and regulations requiring workloads to be contained within a specific geopolitical boundary. If there is no regional cloud infrastructure in that geopolitical boundary, then those workloads or applications need to be retained on premises. An example of such a use case is a financial investment firm that might be subject to local tax, data privacy, or data protection laws. All right, so to satisfy use cases like these, we at AWS recognize that there are some applications that just can't be brought to the cloud. So we thought to ourselves, how do we bring the cloud to these applications instead? And that's why we built our wide array of hybrid cloud solutions. These solutions help drive your organization's hybrid cloud migration and provide a simple, fully managed experience in doing so. So let me give you a quick high-level overview of our service families, and then as I mentioned, we'll be conducting a deep dive into each of these in just a moment as well. So we begin with our classic cloud offerings in the region. Then you've got our local zone offerings in metropolitan centers or industrial centers. We've got our AWS Outposts, which bring the cloud to on-premise locations of your choosing. And then finally, we've got our AWS Snow Family, which brings the cloud to the far edge. Just as you might have a continuum of application requirements, we at AWS have developed a continuum of services that will meet all of those needs. All right, before we move any further, I do want to take this moment to highlight that we've heard loud and clear from our customers that you want a standardized experience no matter where your application is deployed. You want your experience to look, feel, and operate the same way, no matter what service you're leveraging. And in particular, you want to use the same infrastructure, services, APIs, and tools. We've heard you, and we've delivered on this need. Here's a look at some of our hybrid cloud customers. We're working to power companies like Netflix, GE, and Philips, and many more. Here's also a look at some of our hybrid partners, including Slalom, Capgemini, and Sirius. These partners are here to help you with your migration journey, and in total, we have over 100 AWS migration competency partners, all of whom have an advanced level consulting certification, and they're all well-versed in our AWS migration strategies. Okay, so now it's time to deep dive those service families that I introduced. And let's begin where we always do, with where we began as a business, with our AWS regions. At AWS, we have the largest global infrastructure footprint. And at AWS, every region consists of multiple availability zones, which are a fully isolated, discrete data center. Every region provides connectivity to the network and full redundancy. And most recently, we've announced the launch of 8 new regions and 24 new availability zones in several countries, including Australia, India, and Switzerland. And we continue to expand our footprint based on customer feedback. For most customer application requirements, we believe that regions and availability zones provide an optimal choice for your needs. With that said, and as we've discussed, there are often going to be those exceptional applications that do justify keeping those applications closer to your end customers. And for use cases like those, we've built local zones, which brings the AWS Cloud closer to metropolitan and industrial centers. Local zones are a logical extension of the AWS region, and they allow the customers to use the same AWS infrastructure, services, APIs, and tools as you use in region. However, the unique benefit of local zones is that they extend the reach of our regions to additional physical geographies, closer to your end customers. In doing so, local zones provide predictable single-digit millisecond latency. And they also serve applications that are subject to any local data processing requirements or data residency needs. Local zones even provide some of the same pricing benefits that you see in region, including elastic, on-demand, and pay-as-you-go pricing. Let's take a look at our current local zone footprint. So the cities in green, or it looks a bit more yellow to me, indicate local zones that are already launched, and then the cities in white indicate local zones that are announced as upcoming in the next year or so. We've grown from a single local zone in LA to over 17 in the US, and we're excited to build upon that success to continue growing our availability across the world. And many of the AWS services that you know and love using in region are available on our local zones. In many of our local zones, we support many of the core compute and networking services, including various Amazon EC2 instances, Amazon EBS for block storage, Amazon ECS and EKS for managed containers, and Amazon VPC for integrated networking with the region. Based on customer feedback, we are continuously planning to add additional EC2 instance types as well as service offerings on our local zones. With that said, we've got a customer, Jonathan, who I know has leveraged many of these services to drive a hybrid cloud migration at his organization. Jonathan is the Director of Engineering at LegalZoom, and please join me in welcoming him to the stage.
Thanks, Akshata. Hi, I'm Jonathan Hutchins, Director of Engineering at LegalZoom. And here we go. Who is LegalZoom? What is our company? We are a leader in online business formations as well as estate planning. What that means is if you want to form a company, a small business, you go to our site, and then on the back end, we handle all of the fulfillment in order to put it all together. So we wanted to move to the cloud. We were running it in a data center. We had a very rapid timeline, 2 years, 2 data centers that we wanted to get out of. In doing so, we developed a modern microservice architecture, and we're running a number of applications already on AWS, but our existing legacy applications were very tightly coupled, and as a result, we were unable to risk having any latency issues between the systems. So a little bit of facts behind it. It's a 20-year-old fulfillment system. It was developed by a great team that has that over the years added features. As everybody who has their own system on the back end, there's always at every company a server that's sitting in the back that somebody put drywall in front of. Nobody actually even knows where it is or how it works, but it works and it powers the system. So that's a little bit what we were dealing with for our own fulfillment system. So what's the first option that you want to do? You want to redesign it. You want to make it update the architecture and be able to support that. That takes time. That takes a lot of developer dedication in order to do that. And plus, you also have to learn all of the ins and outs of the system that you may not have the internal knowledge about. So we took a two-pillared approach. We're going to redesign the fulfillment system in order to modernize it and solve for that problem. But we didn't want to slow our migration to AWS down at all. So what we ended up doing was we were able to use AWS Local Zones in order to be able to link our data center, where we were running our legacy fulfillment system, to our new modern stack running on EKS, Kubernetes containers and everything. And we were able to benefit from the low latency. It allows us to have our APIs talking back to the old fulfillment system, all of the complicated communication and fulfillment steps that we have. Everything works fine. Latency is just under 5 milliseconds, I would say. And since it's bound to the AWS region, in our case, it's US West 2, this allows us to benefit from being able to launch things in US West 2, as well as if we have something that's latency sensitive, okay, we're going to keep it in the local zone, but it also allows us to expand out into the main region. And so here's a little bit an architecture diagram about of how we have things laid out. If you see, we have it's just an extension of your existing VPC. You have your in our case two separate subnets that are located in the LA local zone, and we can launch things within that same VPC in US West 2 or in the local zone, depending on how we have it. And it enables us to have some Lambdas running in US West 2, some things running local, and through Direct Connect, it's absolutely seamless, the experience. And so, as I said, it's as easy as using just any additional availability zone. That's essentially what it is. It's very reliable. We haven't had any issues with it, and it allowed us to continue to start working on that project to redo the fulfillment system while still being able to lift it and move components instead of having to do one giant lift and shift of our entire system all at once. It allows us to break each piece out and slowly start moving things over into the main into AWS. As I said, less than 5 milliseconds latency. It's very fast for our use case in the data center. And there are certain cases where some services are not supported in the local zone, but the way it's designed is it's so smooth that if it's not supported in the local zone, we can run it in the main region, and it's pretty seamless. And it definitely simplified the migration journey. So, Akshat, I'll turn it back to you.
Thanks so much, Jonathan. It was super interesting getting to hear from someone with real experience driving a hybrid cloud migration. So let's continue our deep dive now and move on to our AWS Outposts, which helps bring the cloud on premises. So we launched AWS Outposts to bring the cloud to customers' on-premise locations, whether that's a data center, co-location, or any other kind of facility of your choosing. Customers have applications with sub-millisecond latency requirements. And for that, Outpost provides a fully managed solution. Customers, as I mentioned, use their Outposts in data centers, co-locations, or any other facilities of your choosing. So an example could be like a factory floor. Our Outpost family comes in multiple form factors. You can see that we have our 42U Outpost racks, VMware Cloud on Outposts, and also our 1U and 2U Outpost servers. So now I'd like to share a little bit more about our 42U Outpost racks. These racks come in a fully assembled rack form that is ready to be rolled into position. You can create an Outpost order in your console by specifying the type of capacity and the scale that you need it, and then also letting us know the location at which you need it. Next, an AWS associate will arrive at your location, what we call the site, and install the rack. They'll roll it in, they'll plug in the power and networking sockets, and every 42U rack comes with a centralized redundant power conversion unit, as well as DC power distribution. Each rack also comes with active components, redundant active components, such as switches and spare capacity. And you can install multiple Outposts in your facility or across your facility based on your availability needs. I'm excited that we've recently also announced the launch of Amazon EKS Local Clusters on Outposts. With the new addition of Amazon EKS Local Clusters on Outposts, we automate time-consuming tasks, such as provisioning lifecycle management of Kubernetes clusters, nodes, and core operational software. EKS on Outposts helps reduce the time that your team spend managing and patching infrastructure and Kubernetes clusters. All right, next I want to introduce you to our smaller form factor, which is our 1U and 2U servers. While our 42U servers our 42U racks are great for data center applications, for highly distributed environments requiring less compute per location, our Outpost servers are a great fit. These servers can be rack-mounted into existing rack space wherever you have network equipment, and each server has lower power draw and bandwidth requirements than our smallest Outpost racks do today. Though this form factor is smaller, it still packs a big punch, as we offer the same AWS infrastructure, services, APIs, and tools that you're familiar with. So let's take a look at our Outpost availability. Today, Outpost is supported in over 73 countries, and many of which don't have a region or a local zone today. We continue to add availability based on customer feedback, and some of our most recent launches include Qatar, Trinidad and Tobago, and Serbia. As with local zones, customers on Outpost run a variety of well-loved AWS services. And some of these services are offered locally, while other services are offered via connection to the region. Some services that I want to call out are Amazon S3 for object storage, Amazon EKS and ECS for managed containers, and then RDS and Elasticache for highly available and performant databases. We have a customer, Anusha, who has leveraged many of these services on Outposts and on local zones to drive a hybrid cloud migration at her organization. Anusha is a senior architect at athenahealth, and please join me in welcoming her to the stage.
Thank you, Akshita. Good afternoon, everyone. Hi, I'm Anusha Dharmalingam. I'm Executive Director and Senior Architect at athenahealth. I'm really thrilled and excited to be talking about our migration journey to AWS and how Outpost is playing a key role in that process. So a few words about what we do at athenahealth. athenahealth is a healthcare technology company which enables our clinicians and patients, partners, and payers connect each other. We support more than 150,000 clinicians using our software, and also we support 20% of US patient population. It's very highly likely that one of you here have either directly used our application or the doctor that you visited was using our application. And our revenue cycle management product, our electronic health record product, and patient engagement portal are primarily built to enable our clinicians provide quality health care for our patients. So that's what we thrive on. Little background about our technology stack. So athenahealth is a company that was started 25 years back. What does that mean? That means that our software has the domain knowledge and business knowledge that we have accumulated over these 25 years, organically grown, catering to all the healthcare needs that US healthcare industry has gone through. And from the technology side, it's a Perl-based web application stack served through Apache web server with a legacy relational database at its backend. From the get-go, though, it was built as like a SaaS product. What I mean by that is it was centrally deployed in our data centers and served to our customers. So what that means is it has some multi-tenancy characteristics built into it. So when we have a new customer, they get their own dedicated web stack and dedicated database instance or schema, depending on the size of the customer. So this enabled us to horizontally scale, catering to newer customers that we needed. This was a great thing for us because we were able to grow without having to do any changes to our underlying architecture. But we did start hitting some scale problems for some of our large customers as we kept growing. Beyond the scaling problems, we also started seeing some of the operational challenges in maintaining our legacy application. So as I said, 25 years organically grown, so you can imagine the kind of code base that we would have, right? It's like a tightly coupled, not siloed, like everything depends on everything, kind of an application software with database systems acting as multi-purpose, like it acts as a queuing system, it acts as a configuration system, it acts as a data lake, and it acts as a storage for our application data as well, right? So multi-purpose usage of the relational data. So all these things means we had a lot of operational and maintenance challenges, and it also slowly started impacting our developer productivity, right? So it was very clear, high time, we need to modernize, refactor our code, and take it to the cloud, right, for all the benefits that the cloud offers. So with that, we began our modernization journey a few years back to AWS. So when we started our modernization journey, we started decomposing our monolith to microservices, and we chose the popular Stangler fig pattern. The Stangler fig pattern indicates to start with your peripheral services, modernize those things to begin with, and then go and modernize your core services. So that's how we started. We started with the periphery services, and any new features or functionalities with the data in it would be done in the cloud. So we started a journey that way, and modernization was going at a great pace. We did a lot of container-based workloads. We use Java as primary language for most of our applications. And these microservices chose their own purpose-built database based on the use case, like from relational to DynamoDB to OpenSearch, depending on what's applicable for that use case. We also had eventing solutions for communication between our microservices, right? And also for communication between our monolith to the microservice, we had eventing solutions through Amazon Event Bridge, simple queue service, and streaming solution using Kafka, right? Also, we had our data lake on S3, and the data lake was filled by the change data capture from Oracle, from our relational database, filling up the data. So that was a cloud world that we are in. Though we were doing that modernization, this refactoring pattern of modernization is really hard, and it's very time consuming. So we were able to do our peripheral services, but as we started going into our core services, we realized that it is taking a long time for us to do, and it's hard. While we were modernizing on one side and removing our code, we also realized that because this was taking a long time, we were continuing to build our Perl code base, because we had to deliver features on our domain that we were not modernizing. So the development teams started building the Perl code, right? They had to keep supporting the features. And also to serve some of our microservices, which are still dependent on our monolith database, we had to build API layers in the Perl code to do so. So on one side, we were removing the code. On the other side, we were kind of building the code. So it was high time we had to pick a solution for this. The other problem we also faced was our developer community, right? So they had to constantly do a context switching between building the monolith style of application on Perl with the CI/CD for that, versus on the other side, teams have to build container-based workload with the cloud development mindset. So that was becoming challenging. Also, if there were teams which were doing only the Perl code, then there was always an interest to move on the other side to do the cloud-based technologies. So we had that thing going as well. So we needed a solution which acted like an extension of our data center, where we are able to deploy modernized code, but still have low latency access to our database, because we were not going to refactor the data yet for some of these pieces. So it had to have a low latency access to our database. So that is where AWS Outposts fit our need. So it provided that solution where we could take Outposts in our data center and build these features which are still dependent on our old data structures in the newer code style using containers and deploy them over there, thereby helping us to achieve what we need, but in the modern code stack, right? And that also helped the developer issues that I mentioned earlier. So they were able to build it either same container kind of architectures, both for the region as well as for the outpost. So with that, our outpost journey. So this is our high-level physical architecture of how we have deployed outpost. So like I mentioned earlier, our monolith application was always served centrally from our data centers. So we have 2 data centers geographically distributed in different regions and serving traffic for our customers based on geo-proximity, as well as acting as a primary and a standby for disaster purposes. So we purchased 2 outposts for each of those regions. So we have 4. This is kind of like our production deployment style. So 2 in the region act for high availability purposes, and we have cross-region for DR purposes. The reliability and availability is very critical for us because it's an extension of our data center. So whatever is currently running and serving our customers should continue to run on Outpost and provide us with the same level of availability and reliability. So for those reasons, we also made sure that 2 of these outposts connect to one US East AWS region and the other 2 connects to US West, just to handle any AWS DR scenarios. And as I mentioned many times, all these were done because we wanted our developers to be able to build container workloads. So we use Kubernetes as our solution. So we have Elastic Kubernetes Service. That's what we're using. So we use the master nodes control plane out of the region and the worker nodes in Outpost. We do also have some applications that are getting deployed in the regions, like our, say, a logging or a monitoring solution, or even our CI/CD workers and stuff like that. They go onto the region because they are not dependent on our database. So we are not required to have a low latency access to database for those kind of things. And also the hardware capacity of Outpost is limited. So we want to use it for the right things, which really need that low latency access to our database. So we deployed our application containers, which connects to database in the Outpost, and the rest of them goes to the region. So the primary use cases that we have solved, like I said, our main reason we are doing this is to curb the growth of our monolith code anymore as we are modernizing. We want to move totally to the cloud, so Outpost gives us the ability to curb any new increase in the monolith code base. So with that, the 2 use cases that we are primarily supporting are, one, where our microservices in AWS need to get access to our on-prem database, either reads or updates. That happens through Outpost. And similarly, some of the features of our monolith is also offloaded onto Outpost as an extension. So those are the primary use cases. So with that, we are continuing our modernization journey. Our goal is to move all of our application onto AWS. And in the process, we are using Outpost, and we will be enabling more such patterns, architectural patterns, access patterns for that. Also, we are exploring on local zone as an alternate because we like the elasticity that local zone offers. But again, the latency sensitivity is why we chose Outpost. So any applications that can tolerate a little bit more latency would go on to local zone. That's our plan. And with that, our goal is to have Kubernetes containers that can be deployed across region or across Outpost and local zone, depending on the dependency it has on our on-prem database and its latency needs. So with that, I'm happy to be presenting on this and giving over to Akshita.
Thank you so much, Anusha. All right, so with that, we're going to move on to the final of the service families that I'll be introducing today, and that's our AWS Snow Family, which brings the cloud to the far edge. For many customers, having infrastructure on premises just wasn't enough to meet all the scenarios they needed. And for these use cases, we developed the Snow family of products to deliver solutions for customers operating in environments with disconnected networking connection. So we consider the far edge to include any scenarios of denied, disrupted, intermittent, or limited connectivity. And some examples of such scenarios include construction sites, oil rigs, mobile environments like ships or autonomous vehicles, and even rapidly deployed military forces. So the first of the services in our Snow family is AWS Snowcone. And AWS Snowcone allows customers to deploy ultra-portable data transfer and edge computing devices anywhere. Each unit comes with 8 terabytes of storage and 2 CPUs worth of compute capability. And this all comes in an ultra-portable form factor that can withstand harsh environments, and it weighs only 4.5 pounds. Some of the most exciting features on AWS Snowcone are that it can run on battery, it supports Wi-Fi connectivity, and it's also anti-temper resistant. The second set of our services that fall under the Snow family are AWS Snowball. And AWS Snowball comes in both compute and storage optimized forms. AWS Snowball allows customers to ingest large amounts of data from the cloud and distribute large amounts of data out to remote environments. With AWS Snowball, customers are empowered to extend the cloud to the furthest, most remote corners of our world. And both of these compact offerings are fit for portable use outside of a data center. You can also cluster these devices based on your availability needs. As with all the other services that I've mentioned today, we run many of our well-loved AWS services on Snow family. Some services that I want to highlight are AWS IoT Greengrass, Amazon SageMaker Edge, Amazon EKS Anywhere, and of course, compute on Amazon EC2. All right. So before we wrap up, I want to remind us again of Diego. With the continuum of hybrid cloud services that we offer at AWS, Diego was able to develop a migration strategy that was simple for his organization to employ. His leadership were excited by the technology offerings and impressed by Diego's problem solving. And I feel like Diego must have felt like a workplace hero that day, nailing his first big project. Now, I'm confident that we've armed you today with the solutions that you can use to drive a hybrid cloud migration at your organization. And I'm looking forward to your workplace heroics, just like Diego. Thank you, everyone, for attending our session today. If you have any questions, myself, Jonathan, and Anusha will be hanging out outside the room, and we're happy to answer those questions one-on-one.